Vector algebra and calculus. We'll proceed discussion in vector algebra and calculus. Vector algebra and calculus, anything you add direction to it and instantly it becomes a vector. What is the grammar of vector is, what is the representation of vector is represented as addition of orthogonal components. This is how vector is represented as addition of orthogonal components. So if I have, or instead, I can say a vector v, if this is x-axis, this is y-axis, this is point is origin. There is a vector like this. This vector is a v vector. How I can represent this v vector? This is a big question, right? Okay, how I can represent a v vector? How I can represent an integral calculus? If someone wants to represent integral calculus, then there is something called limit, lower limit to higher limit, integrand and differential. This is how integral calculus is represented. How to represent integral calculus? Limit, lower limit to higher limit, integrand and differential. Or in more vivid fashion, in more representative fashion, if this is the axis along which integration is going on, then there is a graph which has equation as fx. fx. Now, integration is calculation of the area from a limit that is a, from limit that is b. From b, draw a vertical line. From a, draw a vertical line, and there is a graph, and see where it hits on the graph. Between these 2 points, whatever is the area underneath it, that is called integral calculus. From lower limit to higher limit. Integrand means function, the graph. Differential along which we are calculating the integration. That is x-axis, then it is dx. If it is y-axis, then it is dy. If it is along any axis, if any axis that vector is v, here vector is I, vector is v, then dv. Okay, this is the representation of integral calculus. What is the representation of vector? How I represent a vector? This is x-axis, this is y-axis, this is a vector v. How I represent vector v? Any vector must be represented with addition of orthogonal component. Orthogonal component is x-axis, that is I vector. Orthogonal component is j vector, that is y-axis. If I add these two orthogonal components, it becomes vector v. How I can represent vector v? Consider that there is a vector. Consider, consider this is origin. This is x-axis, this is y-axis. This is origin. Consider one energy that is coming from my y-axis minus y-axis and going towards origin. Consider another energy. Energy means vector. Consider another energy that is coming from minus x-axis and it is passing through origin and going toward the plus x-axis. If these two energy they go and combine at origin, then this together, energy together will move in one direction. That vector is v vector. Now how we represent v vector? Then anyone would say, okay, v vector is looks like it is nothing but addition of this vector and this vector. This vector that is coming along x-axis, this vector is coming along y-axis. If they combine together at origin and they go along one axis, if that is v, then v is nothing but combination of this vector and this vector. Consider this vector is called xi, this vector is called yj, then the v vector is xi plus yj. What is representation of v vector? Representation of v vector is xi plus yj, where xi is called its x component and yj is called y component. Other people may say, actually, there was one vector called xi, there was another vector called yj, and they got combined at the origin and it became v. Many ways it can be interpreted. So this is the notation of any vector. Combination of its orthogonal component is the representation of any vector. Okay, xi plus yj. No, 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 not like that. There is a point called x comma y. From origin, if I draw a line, that is xi plus yj. It is your wish. Okay, many people call it position vector. If there is a point called x comma y and there is a point called origin, if you connect the line, then it becomes xi plus yj. If that is the science, then if there is a point called x0, y0, there is another point called x1, y1. If you connect these two lines, it becomes another vector, that is x1 minus x0i plus y1 minus y0j, the way we saw many fundamental of it. Or someone would say the v vector, v cos theta is x, v sin theta is y. That's why v is xi plus yj. Okay, so many ways someone can think about a vector, but at the end, vector representation is constant. That is the x component and y component. If you add full in addition fashion only, this is vector. Why it is not becoming one? Why it is xi plus yj? I can represent it something like that. Is the v. That is the v, and it is in orthogonal component. Means orthogonal means they are independent to each other. Like I say, if I have two orange and I have one mango, then I say I have two orange plus one mango, because they are independent to each other. That comes from different category at all, and one comes from different category at all. Then two orange plus one mango. Two orange plus one more orange. If I am saying two orange plus one orange, someone will say, oh, you are fool or what? Why you are saying two orange plus one orange? Say three orange, because they come from same category. So x component and y component, see they are 90 degrees to each other. They are from different category at all. That's why it is represented as xi plus yj. It cannot be merged together. Okay, this is the vector representation. Anyway, we are in deep discussion about the energy calculation. Energy, at the end, science comes in energy. Okay, I have too much velocity. I am running with very high velocity. Okay, another person is running at 1/10 of my velocity. Okay, or 1/100th of my velocity. I am running at a speed at 100 kilometer per hour. My speed is 100 kilometer per hour. Another person, his speed is 10 kilometer per hour. Consider 10 kilometer per hour. Okay, my weight is my weight is 20 kilogram. Okay, so my weight is 20 kilogram. I am running at a speed of, I am rephrasing it because computation will be very difficult. One person is running at a speed of 10 kilometer per hour. One person is running at a speed of 1 kilometer per hour. How much this person is carrying the energy? Energy is mass into velocity square. So 10 kilometer per hour, if someone is running, then V square is 100. Consider his mass is 10 kg. I mean, this is very less, but consider 10 kg. So 10 kg into 100 is 1000 is the joule. That is the energy that person is carrying. Okay. Now another person is running at 1 kilometer per square, 1 kilometer per second, but his weight is 2000 kg. Consider like this. So another person, his weight is 2000 kg and his speed is 1 kilometer per square. 1 kilometer per square is considerably less velocity. Okay. So if someone is running at 10 kilometer per second, 10 kilometer per hour, and his speed is 10 times more than a person is running at 1 kilometer per hour, but this guy's weight is 10 kg and that guy's weight is 2000 kg. Now, this person is boasting that I am extremely energetic. I am extremely energetic because my velocity is 10 kilometer per hour. and he is so slow, 1 kilometer per hour. In 1 hour, I am traveling 10 kilometers. In 1 hour, he is merely traveling 1 kilometer. So I am extremely energetic. My weight is less, my velocity is high, everything, my energy is very high. That person weight is 2000 kilogram, heavy, bulky, and then 1 kilometer per hour is his speed, then he is like a dull guy, but not true. Energy is mass into velocity square. His energy is more than you. Okay? At the end, energy matters. At the end, energy matters. Someone is generating energy in how much time? That is called power. Power. If someone is generating of such energy or someone is carrying if the thick guy, if the thick guy, he is generating energy and for some duration. I mean, he is generating 2000 Newton for some duration. This guy is generating 1000 Newton. Okay, I'm not talking about now per hour. The per hour, this is what we are calculating. Considering this guy, or I have 2 unit of energy generator. Okay, 2 unit of energy generator. One generates 100 joule of energy in 1 second. One generates 100 joule of energy in 2 seconds. The energy, like I did like this. Okay, I lost the energy. If I do like this, then when I'm pushing this up, I'm keep on losing energy from my body. Okay, then I generated the energy in how much time? If I divide by time, that is the power. If someone is generating a amount of energy in very less time, then the power is more. That's why power unit is what? The bulb that used to come, or any electrical device, there is a written called watt. Watt means this much energy it generates per hour. I believe watt is not per second, per hour. This much, this much volt, this much volt, this much ampere, then this much is the energy it is generating per hour. Kilowatt, kilowatt. People also in terms of say kilowatt hour. I mean, in power bank nowadays the power bank comes. It is written 10,000 milliampere hour. This is what it is written, 10,000 milliampere hour, 10 ampere hour, 10 ampere hour. And power bank typically comes with 5 volt. Means 5 volt at 5 volt, 5 volt, if you draw 10 ampere current constantly, then it will go for 1 hour. This is what it is saying. If you connect with any device that is pulling 5 volt of 5 volt and pulling 10 ampere of the current, at 5 volt 10 ampere of the current, if someone is pulling, then it will, this power bank will go for 1 hour. Very few people understand what is 10,000 milliampere, 10,000 milliampere hour that is written on the power bank. Power bank is 5 volt. If you connect power bank to any device that is running at 5 volt, for at 5 volt, the device can suck 10 ampere of the current for full 1 hour. After that, zero, nothing. What is the power of the power bank? The power of the power bank is voltage into current. Voltage into current. Okay. Voltage into current. I believe voltage into current is the equation of power only. So per hour, voltage into current, 5 volt into 10, 50 watt. Power is V square by R, or current into voltage. That is the power. So current into voltage, that is 5 volt into 10 ampere by 1 hour. In 1 hour, this much give, but power bank will go for 1 hour only. But my power bank goes for 40 hours, not for 1 hour. Okay. When you are saying power bank is 10,000 milliampere hour at 5 volt, then it is 50 watt power bank is there. Means 50 watt power bank is there, means at 5 volt it will work only for 1 hour. But my power bank goes for 40 hours. Means you are not drawing 10 ampere of the current. You are drawing 10 ampere by 40. That much is the current you are drawing from the power bank. That's why it is going for 40 hours, whatever it is. Now, we are talking about kind of energy calculation. Energy, something that cannot be destroyed. Energy cannot be destroyed. Energy changes its form. So, what is the perfect engineering? Perfect engineering is that in any calculation, if there is something involved, try to bring it into energy condition. That is the most perpetual science, energy calculation and direction. Energy with direction is called vector. Okay, there is a energy that is going through in what direction it is. So energy has magnitude and energy has direction. If you add direction to energy, it becomes a vector. So vector science, we are talking work done through a vector. Okay, so many things we talked about work done through a vector, work done through a vector. Okay, now there is something called path independence that is under discussion now. Path independence, vector, work done. Okay, what we are talking now is that okay, if there is an object that is moving, okay, this is force field. This is a vector force field because there is something energy source that is kept somewhere. There is an energy source that is kept somewhere. Because of energy source, there is a force field. Force vector is in the environment like a magnet. Magnet is kept somewhere, and because of magnet, there is a magnetic field. A powerful magnet is kept somewhere. I am just walking here and there. I don't bother about the magnet. Okay. I say there is no energy here. There is no force field here. Who is saying there is a force field? And then somehow you catch one iron bolt and suddenly it slipped from your hand and it went somewhere that you are not expecting. You expecting that bolt would go down toward the earth. Earth has another magnetic force. Okay, Earth has another gravitational force. Magnet has another gravitational force. If magnet is kept in it is very powerful. If this is the iron in your hand, it slipped from your hand and it went in that direction. Means you are not able to see, but there is a magnetic field in the environment. Consider that magnetic field is this force. And an item is moving from this point to this point. How much energy that magnet is losing when it is making an item move from this location to this location? That is called energy calculation. Energy calculation means how much energy a magnet is losing. Magnet is losing because it is moving an object. Object cannot be moved for free, right? It needs energy. Object is moving from here to here, from point A to point B. That much is the energy that magnet is losing. That much is the energy that magnet is losing. If this is the magnetic field direction and then item is moving from here to here, how much is energy magnet is losing? If item is moving from here to here, magnetic field everywhere, magnetic field in this direction, constant in this direction. If it is magnetic field in this direction, item is moving from here to here. How it is moving from here to here, not here to here, because magnetic field is in this direction. As I have given example, that consider that this is a bolt, and bolt I have inserted inside of this. I have pierced inside this. Now it is receiving a path. Since it is inside this, since it is inside, since I have pierced this inside this line. So the iron is moving along the line because this is a bolt, not bolt. It has a hole and it is pierced like this. Now it will move along this line only. Even though vector field is like this, but it will move along this line. Then how much is the energy the magnet is imparting from inside when it is moving from point A to point B? Okay, then what is the force in this direction? What is the force in this direction? That force into displacement. If magnetic force is like this perpendicular to the direction, how much the energy magnet is losing when item is moving from here to here? Force in this direction, that is 90 degree, force cos 90 is 0. Then there is no work, that is no work is happening when item is moving from here. Then how it is moving from here when there is no work is happening? There is some other magnetic field is there, or it is not moving at all. You are falsifying. That item is moving from here to here under the magnetic field that is perpendicular to the direction. Then it is you are falsifying. There is some other magnetic field is there, or it is not moving at all, because Earth's gravitational pull is also perpendicular to this only, so it cannot move at all. Okay, so we saw that energy or work done by any item is force vector dot displacement vector, or in calculus when force vector is algebraic vector, it is not a numeric vector. When force vector is algebraic vector, that is its component. Force vector is represented through orthogonal components. When orthogonal components are in x and y, not in number, then it is called algebraic vector. If it is called algebraic vector when it is not a number, then the net work then becomes force vector dot d of position vector, not the displacement vector. Differentiation of position vector is the displacement vector. Actually, that is a sign. So if item if item if item is moving from this direction to this direction along this direction, and this is the origin, if this is the place of origin, this is the origin, and item is moving in this direction, then what is the position vector at this point? This is the position vector any point, that is xi plus yj, where y and x are related as per the equation of the line. Then work done or energy that is transferred from the energy source, because it is maintaining a force field, its force vector dot d of position vector. The position vector is xi plus yj, and force vector capital F vector is F1 vector plus F2 vector. Then it is F1 dx plus F2 dy. That is the energy it is losing. Okay. Now there is another thing that is coming as path independent. Path independent in the sense that there is a vector field, there is a force field, and item is moving from here to here because of the force field. Because the force field, item is moving from here and here. If it is path independent, if item is moving from here to here, then energy source is losing energy, because it imparted energy to move an item from here to here. Okay, now instead of item is moving from point A to B in a straight line, item is moving in a circular fashion. Item is moving in a zigzag fashion. Item moving in a parabolic function. But what is constant is point A and point B is constant. Between point A and point B, item is moving in different direction. How much the energy source is losing the energy? If energy source is losing same energy, independent of the path, only begin point and end point it is dependent upon, then it is called the force. Then it is called path independent force. Force is path, because the force only energy is released by the energy source. Force into displacement. If the energy that is released by the energy source, that is magnet, is dependent upon the magnetic field force, and point A and point B only, not on the path, then this force field is called path independent. Or I can say that if in a closed loop, okay, if now this is point A and this is point B. This is point A and this is point B. Now item is moving in this fashion from point A to point B. Now magnetic field is losing energy because item is moving from point A to point B. Okay, there is a work done. Alright, now again item is moving from point B to point A. First point from point A to point B, and then point B to point A. What is the net energy that energy source is losing? Zero. consider it is 0, then also it is path independent. In a circular loop, if item is moving in a circular loop and it is coming back to the same position, and energy lost by the energy source is 0. If it is a circular loop, I mean it is a closed loop, sorry, not circular loop, closed loop from point A back to point A only, any loop, doesn't matter. If item is going from point A to point B, then energy source is losing the energy, and when item is moving back from point B to point A, it is gaining energy in equal sense, then it is path independent. Or item is moving from point A to point B, this guy is energy source is losing energy, then item is coming from point B to point A, it is again losing energy. So net energy that it lost is some energy, then it is path dependent. Okay, path independence means energy calculation is dependent upon begin point and end point. If begin point and end point is same, then there is no energy lost at all, right? That is because of the path independent fundamental. Path independent fundamental means if an item is moving from point A and point B, from point A to point B, the work done or energy lost by the energy source is dependent upon A and B only, not on the path. If B is again A only, from A to B, the integration what we make for the energy calculation is from A to B. Consider it is A to A only, then there is no energy loss, right? So if in a closed loop, if begin point and end point is same, then net energy lost by the energy source is same. Okay, if that is the case, the energy lost by the energy source is same, then it is called path independent. Like as we say, typically we say earth is path independent. The earth energy is path independent in a sense that if I drop an item from here to here, then earth loses energy. And if I drop item in a circular path, then again earth will losing same energy because it depend upon the begin point and end point only. If that is true, then if drop item from here to here, earth is losing energy. If I bring this item here to here back, then net energy that earth is losing is 0. Earth is not losing energy, means earth is gaining energy from this point to this point. That's why I say that earth, the mother earth, is very happy when person go high in their life. Person they rise in their life, then earth becomes happy because it gains energy. If person drops in his life, okay, morally or whatever it is, if person drops in his life, not only dropping like this, drop in his life, then earth is losing energy. Okay, so get higher in your life so that earth will become energetic. Okay, anyway, now path independence means in a closed loop, the net work done from begin point to end point, if begin point and end point are same, then it should be 0. This is also a sign of path independent. What is another sign of path independent? What is the calculation of energy? That is F1 dx plus F2 dy, where F1 and F2 are two components of the force field. Force field F equal to F1i plus F2j along a direction that is dxi plus yj, that is a position vector. Net energy F1 dx plus F2 dy. If this integration leads to an algebraic function g, that is also called potential function, and dg by dx is F1 and dg by dy is F2, then again this F is called path independent because the net integration, net energy calculation g is only dependent upon F only. dg by dx is F1, dg by dy is F2. Okay, and then limit a to b. So net energy calculation is dependent only on F1 and F2 and lower limit and higher limit, not on the path that is xi plus yj. Then it is also called path independent. Next thing what we saw, that if item, okay, if item is moving from point A to point B, this is point B and this is point A, Or example we gave, this is point A and this is point alpha. If this is xy plane, this point is alpha comma beta. If this is x, then this is x comma y. Okay, sorry, a comma b. There is a point called a comma b. There is a point called alpha comma beta. If item is moving under a force field from a comma b to alpha comma beta, okay, then there is a work done. The energy source is losing energy. If there is a work done, then if it is then what is the scenario of the work done when it is path independent? If it is path independent or dependent, from A I draw a vertical line, and this is M. From M I draw a horizontal line, and it is touching alpha. A comma B, alpha comma beta. From A I draw a vertical line. From A I draw a vertical line and it is reaching M. From M I draw a horizontal line, it is reaching alpha. Now in this direction, okay, this is one direction, this is another direction. Anyway, now force field is F1I plus F2J, where the X component is F1 and Y component is F2. X component is F1 and Y component is F2. If that is the case, then if F1, the F1 that is along x-axis, if I take F1 vector, if I take F1 vector at x-axis and parallel to x-axis, if F1 is changing, then there is dF1 by dy, because along y-axis F1 is changing. Like this, if this is F2, if F2 is changing along x-axis, then there is dF2 by dx. There is dF1 by dy and there is dF2 by dx. Okay, if dF1 by dx this is a force vector, capital F is the force vector whose x component I vector is F1. If F1 along x-axis is this much powerful, and after 10 meter F1 is like this, it becomes small because there is a change in F1. Typical example is force vector is y cos x plus y cos x I plus y plus sin x j, where F1 is y cos x, F2 is y plus sin x, that is F2. F1 is changing because there is y. If we grow in y, F1 will become powerful. F2 is y plus cos x. If you go along x-axis, then F2 will change. It will grow, it will decrease, it will grow, it will decrease. If that is the case, then certainly there is dF1 by dy. There is dF2 by dx. If there is dF1 by dy, then force imparted along x-axis, that is y equal to 0, and force imparted at y equal to someone are different. This will make a torque here. This will make a torque here. And in this expression is not available anywhere else. Okay. Now if this is F1, then there is no torque on this. Torque is only on the vertical line. If there is a horizontal line, this is F2. Now here F2 is different and here F2 is different. If there are four different forces are touching this line, it will generate a torque. Altogether, one torque is in this direction, one torque is in this direction. If they nullify each other, means from this point to this point, okay, if I calculate the line integral, that is the energy calculation, that is the work done, then this dF1 by dy and dF2 by dx, they are nullifying each other. In that sense, every moment this force 1 and force 2, change in force 1 and change in force 2, they are nullifying each other. If it is like that, then this is called path independent. Means it is not depending upon the path. It is depending upon the begin point. The net line integral is dependent upon the begin point and end point only. Because along the path, they are cancelling each other. dF1 by dx, dF1 by dy and dF2 by dx, they are cancelling each other. In that sense, it is not dependent upon the path. It is dependent upon the begin point and end point only. If that is the case, then we can say if dF1 by dy and dF2 by dx are same, then it is again path independent. means df1 by df1 by dy minus df2 by dx equal to 0 for path independent. But this is my sentiment. This is my sentiment that if they are together, then they will nullify each other torque. If they nullify each other torque, then it is path independent. Can you prove it? Someone would ask, can you prove it? Okay, I can prove it. Now you know if it is path independent, the work done is f1 dx plus f2 dy. That comes as g as algebraic function. That integration comes as g as algebraic function. And if f1 equal to dg by dx and f2 equal to dg by dy, then it is path independent. This is proved one. Please watch our previous video. Now f1 equal to dg by dx. Now say f1 df1 by dy equal to dg by dx dy. dg dx dy is differentiation of g along xy plane. dx and dy means differentiation of g along xy plane. So df1 by dy equal to dg by dx dy. f2 equal to dg by dy. Now in differentiate with x now. df2 by dx equal to dg by dy into dx. Okay, one is dg by dx dy and one is dg by dy dx. dx dy or dy by dx, that is nothing but differentiation along xy plane. Same. If both are same, then df1 by dy and df2 by dx are same, considering it is path independent. Makes sense? Okay. So if it is path independent, how many ways we can say it is path independent? There are three ways. One, if it is path independent, then in a circular loop, in a closed loop, if someone is traveling in a closed loop, independent it is circular or whatever, circular in a closed loop from one point and coming back to the same point, if line integral or energy calculation is zero, then it is path independent. Okay, one scenario, because energy calculation can be broken. If it is a closed loop, then from point A to point A, that is same as point A to B and B to A back. Point A to B energy calculation, B to A energy calculation. If both energy calculation are same, only difference is in sign. They are anti to each other, then it is path independent because it is zero now. This is one thing. Second thing is, if f1 dx plus f2 dy is the calculation of energy and it resolves into g, and if dg by dx is f1 and dg by dy is f2, then again it is path independent. Or df1 by dy is same as df2 by dx, then again it is path independent. So many things we saw in path independent. So this is we are kind of closing the discussion on vector algebra and calculus, and we will proceed in vector and commercial mathematics. There we will see Green's theorem and flux and those kind of computation. Idea was to start artificial intelligence, but these are required. This is what we are feeling. So vector algebra and calculus, I believe it is all right. Then we will proceed in the Green's theorem under vector and commercial mathematics. So the path independence is the entity that is considered as the most marvelous thing that is discovered, invented, whatever in mathematics. Amazing, mind blowing. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.